So hello everyone, welcome to OneClass YouTube channel. My name is Devansh Purohit and today we are going to go through a couple of popular mathematics question and answers. I'll just give a brief introduction or just a background about myself. So I am in the final year of my graduation and I'm doing my graduation in aerospace engineering. And if you need any homework help or if you need any tutoring help or one-to-one live sessions, then you can check the links in the description below. So without wasting time, let us just move towards our question. First, we have question number 1. It states that what is the limit as x approaches infinity of arctangent? We need to find the limit of x as arctangent tangent inverse approaches to infinity. So for this, we must remember the basic trigonometric ratios of some popular angles. So I remember the trigonometric ratios of tangent of 0 30 degree was 1 over 3 and tangent of 45 degree was 1. Tangent of 60 degree was root 3. Then tangent of 90 degree was it was not actually infinity. It approaches to infinity. So I'll just, here it is exactly 0, but this case is approaching to infinity. Now what I will do, I will take tangent inverse on both the sides. So if I take tangent inverse on both the sides, then I will get 0 equal to tangent inverse of 0. I will get 30 degree equal to tangent inverse of 1 over root 3. Then I will get 45 degree, which will be tangent inverse of 1. Then I will get this will be 45, 60 degree. This will be tangent inverse of root 3. And then finally we have 90 degree. And it will be tangent inverse of now we can clearly see that if we go at the tangent of 90 is infinity, then we can clearly see that 90 degree is equals to tangent inverse of infinity. Now what our question says that what is the limit of x as arctangent or tangent inverse approaches to infinity. Now we can see here that this should be an approaching sign. So, or we should write this like, because it is never touching infinity, it is approaching to infinity always. So we can write like tangent inverse of x, where limit x approaches to infinity. So we can see clearly that when tangent inverse of x is approaching to infinity, where tangent inverse x is approaching to infinity and where x is approaching to infinity, then we can say that this angle is 90 degree, or we can also say that it is pi over 2. Now let's see the solution given by Junior Tutor. So here they have given the solution using graphs. So we all know the graph of tangent of x. With this graph, we can clearly see that at 0, in this y-axis I have tangent, and in this x-axis I have the angle. So we can clearly see that at the tangent of at 0 degree, the tangent is also 0. We can see that it. I'm not sure that pi by 4 will be approximately pi over 2 will be 1.5. It will be 0.75. So at say somewhere here and somewhere here, we'll have tangent of 45 degree, which will be equal to 1. Then we can see the graph is not for this part of the graph or this part of the curve. The graph looks like linear, but as it crosses this line or this point, it is kind of non-linear graph. So we can clearly see that as tangent or as my angle reaches to pi by 2, we have an asymptote. And then the tangent of pi by 2 is approaching to infinity, but the property of asymptote is that it is never equal to infinity. So here we can see that we can observe that the limit as x approaches to pi by 2 is infinity. Since arctangent is the tangent inverse function of tangent, we can swap these values. Therefore, limit x approaches to infinity, arctangent of x equals to pi by 2. The same kind of solution which we did here. So this is one method. We can do it analytically or mathematically, or we can do it with the graphical method. So in this case, we have successfully found the solution, and the solution given by Junior Tutor is correct. So I will just say correct solution. Great job.